Did you know the crunching sound you're hearing right now was engineered in specialized audio labs before the potatoes were even cooked? Because it's not just a snack, it's an engineering marvel designed to break through your brain's defenses and chemically push you to want more. So today, we'll reveal the secret behind the bliss point, why bags are filled with gas, and how these thin slices survive a journey of thousands of miles. And the story doesn't start at the factory, it starts here, on secret farms where very special potato varieties are grown, not the ones you buy at the store. While table potatoes have a high percentage of water and sugar, these varieties, Saturna and Hermes, are genetically designed to be firm and low in sugar. You might ask, why low sugar? Because extra sugar, when fried, immediately turns into a burnt brown color and a bitter taste, and worse, it forms acrylamide, a carcinogenic substance. After that, harvesting begins with huge machines called diggers, which drive their blades to a precisely set depth under the tubers to avoid injuring them. Tons of soil and potatoes are lifted together, and the secret here is vibration. The conveyor belts shake at carefully calculated frequencies to separate the dirt without bruising the crop, because any tiny bruise now will later turn into a black spot in the bag, which means losing millions of dollars. Meanwhile, trucks move immediately because time is the enemy. If potatoes sit in heat, starch starts turning into sugar, which ruins the crop. When they arrive at the plant, the load isn't accepted right away, it has to pass a specific gravity test. Samples are submerged in salt solutions of different densities. If the potatoes float, they have too much water and too little starch, and the whole shipment is rejected. Once approved, the truck dumps 40 tons of potatoes into a rubber-lined receiving pit to absorb shocks. Now the 45-minute journey begins from a dirty potato to a crunchy chip, starting with a first step meant to remove obstacles. The potatoes enter a stone separator that uses strong water currents. Heavy stones sink, and the lighter potatoes float. Then, they move to initial washing through rotating drums with rough brushes that remove stuck-on mud using centrifugal force. After that comes peeling in a brutal but effective way. A drum lined with something like extremely coarse sandpaper spins at high speed. In just seconds, the outer skin is scraped off at a thickness of only microns to keep as much potato flesh as possible, while high-pressure water jets wash away the ground-up peels, which are often sold as animal feed to reduce waste. So the potatoes come out naked and clean. And here, AI steps in for the first time. Optical cameras scan every potato looking for green mold or black spots, and any imperfect one gets knocked off the line at lightning speed with an air blast or a mechanical kick. The survivors ride up to the guillotine, the most important and most dangerous stage in the plant, slicing. This is the factory's beating heart, with a cutting head holding razor-sharp blades made of surgical steel. The potatoes aren't pressed. Instead, they're spun at 100 revolutions per minute, and centrifugal force slams them hard into the fixed blades. As scary as that precision looks, each slice has to be exactly 0.04 to 0.05 inches thick. If it's thinner, it burns. If it's thicker, it'll be soft and not crunchy inside. One potato turns into 36 slices in less than a second. But the blades lose sharpness every 90 minutes, and the line has to be stopped, and the blades replaced immediately to keep the cuts smooth. After slicing, something called starch bleeding happens. The cut surface releases free starch. If that starch is left, the slices will stick together during frying and become a solid mass. So the slices go through an aggressive wash, where water currents and air jets remove every bit of surface starch. Some plants also run the slices through hot water, 80 degrees Celsius, 176 degrees Fahrenheit, for a minute to control sugar color. Now, there's a serious physics problem. Water and boiling oil don't mix, so the slices must be dried immediately using air knives, compressed air streams that shear water droplets off the potato surface. And now we reach the beast. A continuous fryer, 25 meters long, holding thousands of liters of boiling vegetable oil. The moment the slices go in, a steam explosion happens as the water inside the potato instantly evaporates, creating the bubbles on the chip's surface. Special paddles make sure every slice is fully submerged and keep it from floating on top of the oil. At the same time, the temperature isn't constant. It starts very high, 190 degrees Celsius, C, 374 degrees Fahrenheit, to create thermal shock, then gradually drops to cook the inside without burning. The oil is filtered and recirculated continuously every minute to keep the flavor fresh and prevent carbon buildup. In exactly 3 minutes, moisture drops from 80% to just 1.5%. That's where the crunchy texture is born. The slices come out of oily hell, but they're still carrying 35% of their weight in oil. so excess oil is drained right away using mesh belts and violent shakers, while laser devices measure remaining moisture. If it's over 2%, the potatoes will rot inside the bag. After that, they must be cooled immediately to stop cooking, or the stored heat will keep browning them until they burn. Now, the strict quality stage begins. Cameras capture 1,000 images per second of every slice passing by, and algorithms look for dark defects like burnt spots, oily clumps, or green slices. As soon as a defect is detected, a precise air cannon fires a focused puff of air that knocks the bad slice away with surgical accuracy. Rejected chips drop into a separate path, while the golden ones keep going. Then, it's flavor time. The chips enter a huge drum that turns slowly, and the seasoning powder isn't sprayed randomly, it's a whole science. Did you know some plants charge the seasoning with a negative electric charge and the potatoes with a positive charge, so they attract each other like magnets? That ensures every millimeter of the chip is coated with flavor and reduces waste. Though the smells here are so strong, workers have to wear special respirator masks in the seasoning room. The chips then move very carefully on vibrating conveyors, called gentle motion, to prevent breakage. Above is the multi-head weigher, a supercomputer that calculates the best combination of chips to hit the perfect weight. Then it selects 3 or 4 cups, whose total weight matches exactly what's printed on the bag, and drops them all at once. As the chips fall into the packaging tube, we uncover the secret of the air. It's not normal air. Air contains oxygen that spoils the oil. What's pumped in is pure nitrogen gas, which pushes out oxygen and creates an air cushion that protects the chips from breaking during transport. Then, heat-sealing jaws clamp down with high pressure and force to weld the plastic and tightly close the bag. Bags drop at speeds up to 100 bags per minute, while robotic arms collect them and stack them in cardboard boxes in a Tetris pattern to keep them from being crushed. The boxes are then closed, taped, and printed with production dates and destination, and moved into massive warehouses, ready for distribution around the world. Next time you open a bag, remember you're not holding just potatoes. You're holding the product of agricultural engineering, thermal physics, biochemistry, and advanced laser technology, all that work just for that crunch that lasts a fraction of a second. And that's exactly how chips are made.